Question 2. This question is about sodium fluoride, NaF. So immediately I've been given a formula NaF, so I might have to do something with MR to convert it into moles. Some toothpaste contains sodium fluoride. The concentration of sodium fluoride can be expressed in parts per million. That's a concentration we're not used to, so let's work out what that is. 1 part per million represents 1 milligram in every kilogram of toothpaste. Okay, we can work with that. 1 kilogram sample of toothpaste was found to contain 2.88 moles of sodium fluoride. So immediately I've got moles of sodium fluoride, I've got the MR of sodium fluoride. It wants me to work out the grams of sodium fluoride in a 1 gram sample of toothpaste. Okay, so I've got the MR of sodium fluoride, sodium's in Na and F is a 19. So 23 add 19 equals 42. That should be an equals there. So moles is mass divided by MR. Moles 2.88 times 10 to the minus 5, or 0.00028 is the mass divided by the MR, which equals 42. So the mass is these two numbers multiplied by together, 0.00121. Now it wants it in milligrams for every kilogram of toothpaste, so I'm going to multiply that by 1,000, so to get a large unit into a smaller unit, so large into smaller unit, then I'll multiply by 1,000, 1.21 milligrams. Therefore, there's 1.21 milligrams of sodium fluoride in 1 gram, it says, of 1 gram of toothpaste. So if I multiply that up by 1,000, 1210 is the 1.21 milligrams times by 1,000. That gives me an amount not in 1 gram of toothpaste, but in a kilogram of toothpaste, because there's 1,000 grams in a kilogram. So multiplying everything up by 1,000, so there's 1210 milligrams of the sodium fluoride in 1 kilogram of toothpaste, and it tells me here the number of milligrams in a kilogram of toothpaste is also known as parts per million, so my concentration is 1210 parts per million. Sodium fluoride is toxic in high concentration. Major health problems can occur if the concentrations of sodium fluoride are greater than 3.19 times 10 to the minus 2 grams per kilogram of body mass. Deduce the maximum mass of sodium fluoride in milligrams that a 75 kilogram person could swallow without reaching the toxic concentration. Okay, so my first job is to write down the toxic mass, 0.0319 grams in 1 kilogram of body mass. So that tells me the toxic mass, after which point then this sodium fluoride becomes toxic to the person. So let's convert it into milligrams. So I want it in milligrams, so I'm going to multiply this by 1,000, so grams down to a smaller unit value of milligrams and multiply by 1,000. This multiplied by 1,000 is 31.9 milligrams in 1 kilogram of body mass. It tells me what the mass of the person is, 75, so I multiply everything up by 75. So if I had 1 kilogram of body mass now, I multiply it up by 75 to find out what concentration, what the toxic mass is rather in 75 kilograms, multiplied by 75 kilograms, 2390 milligrams. So I've got the amount in milligrams now that's toxic to a 75 kilogram person. The concentration of sodium fluoride in a prescription toothpaste is 2800. Use your answer to deduce the maximum mass of toothpaste in kilograms that a 75 kilogram person could swallow without reaching the toxic concentration. So the concentration is 2,800 parts per million. Let's remind ourselves what that is. That's the number of milligrams in 1 kilogram of toothpaste. So 2800 milligrams in 1 kilogram of toothpaste. So that's the concentration of sodium fluoride in normal prescription toothpaste. A person is allowed 2,390 milligrams before they get a toxic dose. So the person's allowed 2,390 milligrams. There's 2,800 in a kilogram of toothpaste, so they're allowed just less than a kilogram of toothpaste. 2,390 milligrams. They're allowed 2,800 in a kilogram of toothpaste. So if they have a kilogram of toothpaste, then they exceed the toxic level. So let's work it out as a fraction. 2390 divided by 2,800 is the fraction of a kilogram of toothpaste that they're allowed. 0.854 is the mass that they're allowed. Which of these is sodium fluoride? Well, first of all, the answer is B straight off, so I'll tell you why it's B straight first off. So sodium is Na, it has a proton number of 11. It means it's got 11 protons and 11 electrons. But in Na+, it's lost an electron. The plus means it's lost an electron. So it's still got 11 protons, but it's now got 10 electrons. F has got 9 protons and 9 electrons. It's got a proton or atomic number of 9. So it's got 9 electrons and 9 protons. F minus, and minus means it's gained an electron. So it's got 10 electrons and 9 protons. So they've both got the same number of electrons. They've both got the same electron arrangement. 1s2, 2s2, 2p6. 2 add 6 is 10. So they've both got that electron arrangement, but the difference is that sodium, Na, has still got 11 protons, and F has got 9 protons. So Na has got 9 protons, so same number of electrons, same electron configuration, but Na plus has still got 11 protons, whereas F minus has only got 9 protons. So Na plus is a strong nuclear charge, so it's going to attract the electrons, outer electrons more strongly. They're going to come in more closely, so Na plus is smaller than F minus, and that's why it's B.